This podcast is on the renal or kidney anatomy. And basically, the first thing you should think of is what kind of organ is it? It's a solid organ. So what's the predominant tissue, the parenchyma, that does the major functions for this organ? It would be simple cube ET. What's the stroma? Loose ET fen. So now I've drawn a kidney, and here is our kidney. Basically, I did put the indent, which is what you always look for because it's medial, it's towards the middle by the vertebrae. And so that indent is going to be right here. And you want to notice the things that are going in and out of the indented area of the capsule. And so basically, these are the tubular organs that are essentially going to drain the urea/urine and then take it out of the body. So in the indent, the hilus area, you have the renal artery coming in, you have the renal vein coming out, you have the ureter, the big urea tube right there, the ureter, you have the bladder, and then the urethra going on out. And then what else is in the indent area? Basically, we have renal nerves that are under the control of cranial nerve number 10. All right, so that is the hilus area. So it's artery and vein, the ureter, and basically the nerves coming in and out under cranial nerve number 10. All right, now the kidneys, here's a picture of the kidney, and the kidneys and the ureter both are lying underneath a membrane. And the membrane, abdominal membrane, is usually called parietal peritoneum, but because these are sort of like hot-pocketed behind it, they're hot-pocketed behind so that they're held vertical so that they will drain correctly. They call it, not the parietal peritoneum, they call it retroperitoneal membrane. And so retro means something is stuck behind the membrane to hold it in place. And so very important that the kidney sits vertical in the abdominal cavity. So basically I just put a little bit of a retroperitoneal membrane here made out of simple squamous dense reg and put it over here and on top of the ureter so that you can remember that those two organs are held in place by that membrane. All right, now when we go inside the kidney, first of all, we have to have an outer membrane or structure holding the kidney together, and that would be the renal capsule. So the renal capsule up here, I have it as purple going around, simple squamous dense reg, and it's called renal capsule. Common name, kidney capsule. All right, now you'll notice on the outside of the kidney capsule, all the way around the kidney, you can find fat pads, okay, adipose CT. And so we just call those fat pads, and they give it a little bit of protection. And so renal adipose, okay, renal adipose is the name for the fat pads. Now you will also notice, especially when we dissect the cat, or in the cat podcast, you will see a big, large area of fat superior to the kidney. And so it sits up there almost like a little hat, but it looks like a fat pad, but that fat pad actually has within it the adrenal gland. So they call that superior fat pad, which has the adrenal gland embedded in it, the adrenal gland right there, okay? So the adrenal gland is embedded in the superior renal adipose. So in identifying it, if you say name this organ, it's always called the adrenal gland, even though it looks like a fat pad. All right, and so now we've got the capsule, renal capsule, and now when you open this up, you're gonna see that the kidney is divided into two general areas, especially by the color of the tubes in the inside. And so the two general areas for all solid organs, every solid organ has an outer area underneath the capsule. And this outer area underneath the capsule is called the cortex, okay? And so if they say cortical bone means the bone right underneath the capsule of the bone, which is the periosteum. And so anyway, that's the cortex, the outer area. And then everything in the middle is called medulla area or medullary area. Like bone marrow cavities are called medullary cavities. And so those are where those terms apply. So if you're like in this classroom, the wall area, if you're sitting against the wall, that's the cortical area, the walls. And if you're sitting in the middle on the desk, that's the medulla area in the middle. All right, so we got those areas down. Now, basically, what you're gonna find is the ureter is right here. And when the ureter comes into the kidney, immediately there's this big opening. It looks almost like a swimming pool or like a big lake area. And so they call this big area right here the renal pelvis, okay? And then the renal pelvis is going to give off these like little finger-like areas. So if you call the renal pelvis the lake, then these things that look like fingers going up, basically these are called a major and a minor because it's bigger and smaller. Major and minor calyx, that's how you pronounce that. And so major means it's the bigger part, the lower part of your finger, and then it's going to get thinner. Minor calyx. And so major, minor calyx. And so these look like little rivers going up. And then they sort of stop. You can't see anymore. So the big area that looks like a swimming pool or a lake in the middle is called the renal pelvis. And then the rivers that are going to feed into this big lake would be called the calyx, a major and minor calyx. So all of this is in orange because everything in here is made out of simple QBT. So the calyx is also simple QBT, all of this same thing, simple QBT, making up the wall of this structure. And it's a structure, all right? It's in the inside of the kidney. All right, now the calyx basically comes up, and then we have these little tubes out in the cortex right here. Out in the cortex that are going to drain into the calyx, and just one of these structures right here, just one of them right here, this whole thing is called a nephron. And the nephron is the filtering tubes that actually make your urea/urine eventually. And so the nephrons, you have thousands of nephrons in the outside area, in the cortex, right here. And so basically, it's just like a series of tubes, straws/pipes, like even underneath your sink. Look underneath there, and it sort of reminds me of this. And so that's what a nephron's gonna do. And so basically, here are the nephrons, and we'll be teaching you the parts of a nephron in the next couple videos, and then you'll understand all the parts. But if I labeled one nephron right here, just using abbreviations, going backwards, this big long one is called an ST, a straight tube. And then this one that arches over is the AT, the arch tube. And then the one coming down here is the DCT tube. And then right here is the LH, loop of Henle tube. And then the one coming up here is called the PCT, proximal convoluted tubule. And this thing that looks like a U, that's like a funnel right here. It's like a funnel. And so that is called Bowman's capsule, the BC, right there. And so those are the parts, and we will go over this in the next video extensively, how the nephrons work, because these are the structures that actually do the work for the kidney, absolutely. So now, in between the rivers here, the calyx, we have areas that are going to be a darker color when you actually physically look at the kidneys. And these areas are called the renal pyramids, And so these areas are renal pyramids. They have a space underneath them, at the tip of them, at the base, right here, and that's called the renal sinus, right here, the renal sinus. And generally, the point or the tip of the papillae is called the papillae right there. And so that is the renal papillae, is the at the base of the pyramid right there. All And so these are made out of, these papillae, they're actually made out of what's in the inside of them, straight tubes and arch tubes from the nephron. Now, to explain the nephron a little bit better, besides a picture on the board, I made something. I know you're going to be laughing about this, but you'll always remember it. Especially my nursing students really need this information, and it helps clarify what these tubes actually look like. So right here, I have one plain nephron right here, and then I have a second nephron over here, but I have incorporated the blood vessels, the renal subcircuit with it. So we'll worry about this one next. Let's just look at a plain nephron. So basically, here is a funnel-like structure, and this is called Bowman's capsule. And it's made out of simple squamous ET, and it actually looks like a funnel. And what's going to sit in the funnel is that twisted capillary, the twisted capillary known as the glomerulus, is going to sit in the inside, and it drips out plasma all day long, right? And so it's going to be dripping the plasma into the funnel, and then the plasma is going to go down these tubes, and then something happens to it, all right? So basically, this is called Bowman's capsule right here. Then the next tube that comes down, the orange straw right here, this is called the proximal convoluted tubule, and so PCT. And so this is a simple QBT, and the plasma is going to go down here, and then things are going to happen to it. And then we come down to the little green straw right here, and it makes a loop. And so this is called the loop of Henle, after Dr. Henle. So that's simple squamous. And then we're going to come up this twisted tube again, the blue one. And so now this is called the DCT, okay, the DCT. And so distal convoluted tubule. And then it's going to arch over. It's going to arch over, and that's called the arch tube, simple cube again. And then there's this big, long, yellow, straight tube. And then the straight tube is going to drain into the minor calyx, which is this baby bottle nipple thing. So this is the minor calyx, this is the major calyx, and then all the urea and the water is going to come down into the big lake or swimming pool here, and that's called the renal pelvis. And then what drains the renal pelvis? The ureter right here, the ureter or ureter. And then, of course, I didn't build a bladder because I should just put a balloon on there, and that would be the bladder. Okay, great. So anyway, that is a nephron. So the nephron goes from the glomerulus, PCT tube, the proximal convoluted tubule, the loop of Henle, the DCT tube, the distal convoluted tubule, the arch tube, and the straight tube. And that is the basically the filtering tube. Now, when I add blood vessels to it, because blood has to come in here and drip out the plasma, so now I have to add the BVs to it, okay? And so basically, right here is the glomerulus, right here. And this would be like the afferent arteriole, the glomerulus that's going to sit in the Bowman's capsule and drip, and then efferent. And then the efferent, basically, arteriole is going to become the vasa recta. So this capillary right here is going to basically go on top of all the tubes, and then eventually the vasa recta will become the venule, and then it's going to go out of the kidney. And so that's how that's going to go, like that, okay? And so every nephron has its own blood supply, and this is what it's trying to show you on this sheet in your lab book, that I'm also posting on Moodle, and so it shows you how the nephron is connected to the renal subcircuit right there. And so now, another way to imagine all this, to make it a little bit easier, besides what I have right here. So basically I've got my nephron that's going to drain into the minor calyx, the major calyx into the pelvis, and then the pelvis gets drained by the ureter. All right, now, if you use your hand, just go like this. You can pretend, here are the nephrons, okay? Here's the nephrons up here. And so you can say the top of your finger is a minor calyx, major calyx. Then the urea goes in, the water and urea goes into the palm of your hand, which is the renal pelvis. Your ureter is your arm, and your armpit, the axillary area, is the bladder. End of story, right? And so that's another way you can remember it real fast instead of remembering my clever little contraption right there. All right, now to end this, I'm going to go ahead and draw in and destroy my beautiful picture up here with the blood vessels, okay? The blood vessels of the renal subcircuit. So basically, right here comes the renal artery, okay? Renal artery is gonna come in, and when the renal artery comes in, immediately it splits. Remember, it's gonna split. And so this is the what? The segmental artery, the seg artery, right here. And then it's gonna make the lobster claws right here. And so these are gonna be the lobar arteries right here, lobar arteries. And then the lobar arteries, they are going to split, remember? And so they're gonna make some little ones like this that tend to go up the calyx. And so these will go up the calyx like this. And so these little ones going up the calyx, all the calyces, all of those, these are called the interlobar arteries, the ilobars. Ilob arteries go up the calyx. Ilob arteries. So they're going to come up here. They're going to come up here like this. They're going to come up. And then they have to all connect to each other. They got to connect. And so the interlobars are going to go like this to each other. They're going to go across, and they're going to connect and make, guess what? Arcuates. And so here are my arcuate arteries. The arcuate arteries are right on top of the renal pyramids. And so right at the junction of the cortex and the medulla, right here. So now watch this. So now, what comes off the arcuate artery? The big long artery that's going to go straight up. And so what is this called? This big long straight one? Interlobular artery. The ilobular artery, right there. Interlobular artery. And then it's going to turn and go towards the Bowman's capsule right here. And so when it turns right here, it's going to be the afferent arteriole. The afferent arteriole when it turns. And then it's going to become a glomerulus, a twisted capillary. And the twisted capillary is going to sit in here, like that. And so that's the glom, right there, twisted capillary, okay? And then it becomes, it's going to come out like this and become the efferent arteriole. Efferent arteriole as it comes out. And so now the next thing it becomes is the vasa recta. And so the vasa recta is going to come down and it's going to give off all these branches that are going to cover these tubes. Right, and they're all going to cover these tubes of the nephron. And so this is the VR. The VR vasa recta, right in here. That looks like a big bad toothbrush or a fork. And so it's going to send off little capillaries that are all going to be connected to one big one up on top. And so it's going to be up on top and it's going to go down and around all these tubes. And then now we're going to connect all this. And so basically all of these are going to get connected, these little capillaries, and turn around. And so now that is called the venule. The venule right there is going to collect all that blood and turn it around. The venule. And then it's going to go back down right here. And so then that's called what? Interlobular vein. I lobu vein. Right there. And then it will take a ride on an arcuate right here. An arc vein. Right there. And then once it's in the arc vein, it's going to go down the calyx right here. The I-lob vein, interlobar vein. And then once it keeps coming down, it's going to go on a lobar vein. And then it's going to go up the seg vein. Whoops, a little bit too far. And then the seg vein is going to go right out and hit the renal vein, right like that. And so that's quite complicated, but it has great architecture, and we are actually going to see this architecture when we look at the dissected pig kidneys. We are going to see the renal subcircuit, most of it, and then we're going to see all these structures inside the pig kidneys. And so it will make much more sense than just looking at a picture of it once you see it for real. So the only part of the renal subcircuit that you cannot see visibly is basically you can see the interlobular arteries and veins, but you cannot see the arterioles and the glomerulus and the vasa recta. And so you can't see this little integral part. Can you see nephrons? No, they are microscopic. Microscopic, like little bitty thin, micron level tubes. So you cannot see your nephrons at all. They're just brown tissue inside a kidney. All right, so that's the basic anatomy of the kidney and how it's sort of put together. And so on the next several podcasts, we're going to talk all about the nephrons and specifically what they do.